Today our lesson is called Freddy Revisited. I'm going to go back to that fried Freddy and take a look at his probabilities, and we're going to be able to examine the independence of events using two-way tables and find out if events are independent. So as we take a look back at fried Freddy, look at all that good fried food there. Doesn't that make you hungry right now? Makes me ready to eat a fish fry. Friday night fish fry. That would be good right now. Anyway, Tyrell helped Freddy out in determining the amount and type of food Freddy should prepare each day for his restaurant. Freddy's food waste decreased dramatically. Still, Freddy noticed that during the week he seemed to have more food prepared than he needed. Sometimes in the weekend he'd run out of something he needed. Tyrell said another level of determining waste could be if Freddy averaged the number of orders he received of fish and chicken on a weekday compared to the average number of orders he received of each on the weekend. Freddy thought this was a great idea, so he started collecting the data. After 2 months, he had enough information to create a two-way table representing the average number of orders he received on the weekdays and on the weekends for fish and chicken. So the data is below. I'd like you to read through the data and make some observations. What do you notice? What do you wonder? Explain to Freddy what this means. When does Freddy seem to have the greatest business? Should he expect a greater percentage of customers to order fish during the week or on the weekend? What other things do you notice? Then secondly, does the number of orders of chicken compared to fish depend on whether it's weekday or weekend? Which values from the table will tell you that? So I'd like you to take the time to answer those two questions. And when you're ready to see the explanations that I have, let's restart the video. So pause it now. Okay, so hopefully you had some time to make some observations of your own. Here are some of the things that I noticed. I noticed that, first of all, Freddy serves more fish. 186 out of 153, which was about 55% of the total. I noticed that on weekdays, it's about 45% of the total was chicken. Weekends, 45% of the total was chicken. Same with fish, 55% of the total, 55% of the total, and overall it's 55%. So as we take a look at that, we kind of notice that, well, it's the same whether it's a weekday or a weekend. And that's what we refer to in probability as independence. Two events are independent if they have the same probability no matter when it's occurring. It would be dependent, we would say, well, if the chicken is served more during the weekday while on the weekend, maybe for your Friday fish fry, we're serving more fish. But it appears that people are eating chicken and fish at the same rate, whether it's weekday or weekend. So we'd say those events are independent. One way to show that using multiplication relationships is, one way to say is, well, probability of chicken given weekday. That ends up being the same as probability of chicken anyway. Let's consider that it's a weekday. What's the probability of chicken? 45%. That's the same as probability of chicken overall. So we'd say those are way to show independence. And one way we list that, as we look at question 2, the number of orders of chicken compared to fish depending on whether it's weekday or weekend. No, it's independent. And what values from the table tell you this? Well, as we take a look at that, we look at the comparisons. As we mentioned already, comparisons of the percentages of the total during the weekday, the weekend, and the total. They're all the same. So one way we list that is when we put independence, one way to test for independence. So here's one way to tell if events are independent. You're probably going to want to write this down somewhere. So events are independent if the probability of A and B is equal to the probability of A times the probability of B. They're also independent if the probability of A given B is equal to the probability of A and B divided by the probability of B, because that would mean that there's no overlap there. It's just A or B. And the probability of A given B would also be the same as probability of A, because there's no change depending on the circumstance. So here's an example. Probability of chicken in the weekend. Well, if we look at chicken in the weekend, there's 88 out of the 339 that were both chicken and weekend out of the total. and that's about 25.9%. Probability of chicken is 153 out of 339. Probability of it being a weekend is 195 out of 339. If we multiply those two together, we get 25.96. So it's the same. So those events are independent of each other. If we can just multiply the two events together, it should give us what they are combined because there's no overlap, or no change. Rather, there is overlap, but there's no difference between them. And then probability of chicken given it's the weekend is the probability of chicken and the weekend. And we divide out the probability of it being the weekend because that should just be the probability of it just being chicken. So same thing, 88 out of 195 because there's 88 out of the 195 that were chicken, well also the weekend. And we divide those two probabilities and we get the same thing. So if those were different, we would know the events are not independent. So just keep in mind that this is a way that we can tell if events are independent. If their probability combined is the same as one probability times the other, or if probability A given B is the same as the probability of A. Okay, so you'll go through the assignment in class. You can skip through the quadratic function review if you wish. Otherwise, if you want to review x-intercepts, y-intercepts, line of symmetry, and vertex, remember vertex is line of symmetry is negative b over 2a. This will help you prepare for Algebra 2 again. Vertex then, the x-coordinate is negative b over 2a, and then you just plug that into the formula to get your y-coordinate. X-intercepts are the zeros of the function, and the y-intercept is your c-value when it's set up that way. Otherwise, you want to review determinant independence using the rules of independence that we talked about. And then look at probabilities using the two-way table. And then we'll get into our last lesson. So if you have questions, I'll help you out in class.